Am I audible? Hello. You will please tell. Hello.
Yes, Dhruv, you are audible.
Okay. So let's wait for 2 minutes. We only have the 14 participants now. So okay. So I guess we should start because nobody is joining. So welcome everyone. My name is Dhruv, and with me is my co-mentor Devdar Patil, and we are going to offer you the project Suggesteria. So it is a recommendation system, as you all know, I guess. And today's session is taken only by me because my partner is busy in something. So let me quickly share the slide first. Is it visible?
Yeah.
So, so I just roll down this sheet. If anyone have not given the details, please fill it first. So okay, let's start with the word documentation that I guess most of you have already read. So you have applied for this project. So what is suggested? So we are going to basically develop a recommendation system. And what is a recommendation system? It is basically a machine learning field that help us to predict what is liked by the what is liked by the future customer based on his past choices. So that is basically the recommendation system, and we are going to develop it. So, for example, the scenario is given like you are watching a movie and then you wanted to see another film, and then the model will automatically recommend you the other based on your past preferences. So the logistics are pretty much clear. We are going to use the Python. It is this the basic language for the machine learning. There are some libraries written down there, and I guess this is the pretty basic stuff, so we can skip it. And then the evaluation metrics is basically the attendance, which I feel today is very low. So maybe from next time we have a huge participation, and there are going to be weekly assignments and a final project. We are in talk with the leader to modify this evaluation scheme as we are having a large number of participants for now. But if anything changes, I will inform you in very soon. So the basic timeline is the theoretical introduction to the recommendation system, the stuff that we are going to cover now itself, and then there are pre-processing for the week one, and all other is given here only. So I hope everyone have the clear understanding of the key stages if you have read them. Maybe some of the things are not pretty much clear for now, but wait for the project to roll down, you will get pretty much hands on everything. So this already we have exceeded the 25 participants limit, but no worries for that. So actually we are going to have the attendance sheet, and that's why I rolled down the sheet. I know it's pretty late to roll down an attendance sheet, but let's take a quick responses from you. So I will be taking the name, and if you are present, please say present. So Rudransh, are you there? Okay. Aman Ahuja.
Yes, I'm here.
Hello, Rudransh is present.
Okay. Sanchit,
Yeah, I'm present.
Keshav,
Yes, I'm present.
Shoham,
Present.
Harrison. Okay. Ishan, Shivanshu,
Yes, I'm present.
Shivanshu,
Yes, I'm present.
okay. Nandini,
Yes, I'm present.
Deepak,
Ishan is also present.
Deepak, Amir, Khushi,
Yes,
Priyansh,
I'm present.
okay.
Present.
Abhishek,
Present.
Anurag,
Present.
Srihari,
Sri Hari present.
okay. Pranjal,
Present.
Vishal,
Yes, present.
Shivam,
Present.
Manoj,
Present.
Shudhanshu, Tamil Selvan, Kshitij, Himanshu,
Present.
Tamil Selvan present.
okay, one by one, please.
Tamil Selvan present.
Okay. Kshitij, Himanshu,
Present.
Abhishek,
Present.
Adil,
Present.
Ayush,
Present.
okay. There are no names ahead. So I just want to give you a brush up that we are going to have a attendance for few sessions from now. So I guess everyone has an editing option for now, so we can change it. But from the next time, please be on time and be ready with your attendance. Be ready for that. Okay. And
हेलो
okay,
या ध्रुव एक्चुअली मैं लेट हो गया था थोड़ा
what happened?
हेलो हेलो एक्चुअली आई गॉट लेट सो आई वाज नॉट एबल टू मार्क द अटेंडेंस
What's your name?
हाँ आमिर
This right?
Yeah.
Okay. So
Actually, hello.
yeah,
Hello. I got also late and I didn't got marked also.
what's your name?
Abhishek Kumar.
Abhishek.
Abhishek Kumar.
Yeah, I got it. It's already present.
Not this one.
Okay. Have you
It's
filled the
double two
details?
0045.
Have you filled the
Yes.
details? 22?
220045. So wait a second. Let me fill it. I just forgotten.
Okay, let's not wait the time. We can handle it after some time. So I just wanted to give you a theoretical review for now. So these are the slides that I have prepared and also updated in the document. You can already visit them. So
Okay.
let me present the slide. Just a minute. Okay. So this is a project, Suggesteria. So I guess, yeah. So the recommendation system. We are going to basically build the recommendation system. So what is a recommendation system? As I already taught, it is a class of machine learning that uses the data to predict and narrow down the things or the items that people are looking for from the exponentially growing number of options. It's a basic stuff. Like these are the options, and you want to recommend anything to your user that what he or she prefers, then you would rather use a recommendation system instead of a person to recommend anything to your user. So they can be based on various criteria like the past purchases or the search history or the demographic information. But the data collection is also important, and the models that we are going to build is pretty much based on the data that we have. Like if we have the information about the demographic of any user, then we are going to use the demographic based recommendation system. Like Google News uses such recommendation system, and these are trained to understand the preferences of the user. Like we don't know how the user will respond to our recommendation, but we know its past preferences, and we can recommend the item based on its past preferences. Suppose there is an thing like if these are clothes that we recommend to a user and he or she didn't like it, then we recommend another pair of products and he or she didn't like it. But then if we recommend this quote to our user, he likes it and give us a positive feedback, then we know that the user might be looking for some formal, and that's why she or he did not like the previous product. Okay, so I'm talking about the data. So how we get the data to train our recommend system. So as the slide already told you, there are two types of feedback that we usually use for the data collection for our recommendation system. Like there is an explicit feedback mechanism and there is an implicit feedback mechanism. What is an explicit feedback mechanism? In which user gives a explicit feedback for our recommendation. Suppose we have we have given a recommendation system about this flower plot, and the user gave us a customer review or a rating. Like there are 5-star ratings given by the 62% customers and so on. So it comes under a explicit feedback mechanism because in this the user has given us the explicit feedback whether he is satisfied with our recommendation or not. And there is also an implicit feedback mechanism. Suppose there is a browsing history in which people get uh, directed to the some of the pages in which they might not get satisfied as you are searching for some content and you search on the Google, you get many recommendations, but you are satisfied only by some and not by all others. But we only know that you have clicked on the recommended pages. So might be we think that you have satisfied with these pages or not. We don't know explicitly you whether you are satisfied with these pages or not. So based on these types of feedbacks, we have the implicit feedback mechanism in which we give the recommendations, but we don't know whether our user is satisfied with our recommendations or not. Let's move ahead. So what are the companies that use these? So pretty much all the companies, like from the Google to Amazon to Spotify to Instagram to Netflix, everyone use some kind of recommendation system because now all the e-commerce, all the content is on the online platform, and there is no human interaction involved between the purchase or the trade. So we need recommendation system because there are large amount of data and large amount of products that a person can think of to buy, but we need to guide him for selecting a particular. So basically, there are three categories in which recommendation systems can be divided. So first is the collaborative filtering, second is the content-based filtering, and third is the hybrid method. So do anyone know what these collaborative filtering or content-based filtering or hybrid filtering mean? You can just give a thumbs up. No one? Okay. So let me continue with the slide. You will get a fair bit of idea. Yeah. Okay. So the collaborative filtering. So the collaborative filtering is based on the preference information of many users. Like we are dealing with a lot of users in the same time frame. So we use the preferences of these users to predict the items that are liked by some particular group of users. So basically, we cluster the users based on their preference. The key idea is that if some people have made a similar decision in past, they are going to be more likely make the same decision in the future also. And there is a high probability that they might like the same thing in future. So let's have an example. Suppose there are two persons and they both saw two movies in past, and we only have this amount of data available. And then this person also watched a third movie. We don't have any specific feature or specific or attribute about our user or about the movies, but we know that these two users are very similar to one another. So if this person likes this movie, might be this person also likes this movie, and we recommend this movie to this person. I hope I am clear. Is there any doubt? Okay, we can move ahead. So opposite to that is the context-based filtering. So it uses the attribute and the features of the item. It do not use the collaborating based method. It uses the context based. So it clusters the item, not the users. In the collaborative filtering, we cluster the users, not the items. We do not have any specific information about the items, like what are the attributes, whether it whether it falls in a particular genre or not. But we know that the users are like the users like this kind of content, so we recommend that content only. But in this, we know the attributes of the items itself. So as you might guess, it requires a lot of data than the collaborative filtering, because in this we need to know the attributes and features of each and every item. So the key idea for that is this is preferences do not change quickly. So if someone liked an item in the past, then there are high chances that he will be going to like the similar items in the future also. And based on that, we used the content-based filtering. So here is an example for that also. So it is a very similar example, but now we know the genre and the cast for these two movies, and we know that this person likes these two movies. So we find a similar movie that is based on the same genre and on the same cast, and then we recommend this movie to the person. And might be our recommendation. Is there any doubt? Okay. So there are also hybrid recommender systems that are high level recommender systems that use the advantages of both collaborative filtering and content based filtering. As you might guess, there are advantages of data collection in the collaborative filtering, but there are advantages of personalization, content based filtering. So these are the hybrid recommender systems also that use both the advantages and are beneficial for the large organization. Like YouTube has content based filtering previously, but recently they changed their system to the hybrid recommender system. Okay. So is it all? Like we have read about the three filtering, and now we can develop the recommender system. So the answer is obviously no. There are much more on the algorithms part of it. So let's take an example. Suppose there are three users, Ted, Carol, and Bob, and there are three items, and these are the ratings given by the users for the particular items that they use. And if they haven't used any item, there is no rating given by them. So this is the sparse matrix based on their interaction. So what we are going to do with the matrix factorization is that we try to fill this sparse matrix. So it is a collaborative filtering method. Like matrix factorization is used in many applications of machine learning, but in collaborative filtering, it has a pioneer stone. And now we fill this interaction. And if we are able to fill this interaction matrix beforehand, then we can predict whether the future rating given by Bob for the item C is high or low. And based on these ratings, we can recommend the item to the Bob. So let's move forward. So it's the same thing that sparse matrix. It approximates the sparse interaction matrix. So the U by I, U is for user and I is for item only. So by two dense matrix. So let's see here. Okay. So we have the rows for the users and columns for the item. And we have a sparse matrix here. Now we want to fill this matrix fully. So how can we do this? We can see a single matrix as a multiplication of two matrices. Suppose there is a 4 by 4 matrix that we want to fill, then we can use a 4 cross 2 into 2 cross 4 matrix to approximate the sparse interaction matrix. So how we are going to do this is like learning the embeddings for user and item. So suppose there is a person Ted, and we don't know the attributes for Ted, but we can learn implicit, latent, or hidden features for Ted by calculating these numbers, which approximately give us the sparse matrix. Let's see how it's actually. So basically, we factorize our sparse matrix into product of two dense matrices. So first one is called the user factor matrix, that is of size U cross F, and then we have the item factor matrix that is of size F cross I. So F is the number of features that we have learned from the embeddings. So it is pretty much like a non-supervised learning thing. User factor matrix try to describe the latent or hidden features of each user, and we can see each row of the user factor matrix as a learned feature vector for the user. And similarly, we can have an interpretation for the item factor matrix also. So there's a thing called alternating least square. We are going to implement this algorithm. It is basically an alternating optimization algorithm. The alternating optimization algorithms are pretty much familiar with every field of the M. And this one is used in the recommendation system. So it basically tries to minimize the squared loss function. So I hope everyone knows the squared loss function as of now. So more specifically, it takes the Frobenius norm and then minimizes it. So if we can see, like there are two matrices, and we are going to approximate this matrix, this sparse interaction matrix, with the product of these two matrices, that is the user matrix and the item matrix. But we will not be able to get the exact matrix on the LHS by the product of two matrices on the RHS. So what we will do is we will subtract the matrix on the LHS with the RHS and then take the Frobenius norm of this matrix. Do you guys know the Frobenius norm? Okay, no answer.
No.
Okay. So what the Frobenius norm is, basically, we take every cell and then square it and basically sum all of them. So like you have taken the Euclidean norm for a vector, it's the same thing for a matrix to take a Frobenius norm. I hope it might be clear, or I might give the result. So what does the alternating least square algorithm tries to do? Basically, we try to find two matrices simultaneously that will whose product will give the final matrix on the LHS. But what happens is that to find two matrices whose product gives this matrix is a NP hard problem. So doing that with a perfect algorithm is not exist for as for now. So we resort to a ALS algorithm. So what it do is it basically fixes one matrix for now. Like it randomly selects a matrix. Like suppose we have selected a user matrix and then we fix the user matrix and then we try to find the item matrix for minimizing the Frobenius norm. And then we fix the item matrix and try to find the user matrix alternatively. And if we repeat these steps multiple times, then it converges finally. So the changes in the user matrix and item matrix will not be much higher after doing it many times. So basically, we get the final answer at the last of the conversion. Okay. So neural collaborative filtering is a recent topic. It is developed in 2017 nearby. So what is neural collaborative filtering is that it's a nonlinear version of the matrix factorization. Like we have seen before, the matrix factorization only takes the linear relationship into account between the user and the item. Because if you see, we are taking only the product of two matrices. And if you can see, the row matrix is only going to be multiplied with some of the constant and then going to add up to give a particular cell. So it's a linear method. But if there are non-linearity in the relationship between the items and the user, then we have to use something called the neural collaborative filtering, which is shortly given as the NCF. So what we have in NCF is, like in the matrix factorization, we input the user and the item as the one hot encoding vector from the input layer, and then it converts into the embedding layer. I hope the embedding layers are clear from. Okay, so we only have the 10. Okay, so the embedding layer is basically the matrix factorization that we are doing in the previous algorithm. So after getting the embeddings for the users and the item, we basically split them into a multiple perceptron layers in neural network. So like here it is written as the neural collaborative filtering layer. They are basically the multiple perceptron layer. We can also change the architecture here. So the math behind is pretty complex and I don't want to show it on the slide. So I have linked the original paper here. If anyone wants to go for that, you can go for that. but we never have to implement it with our own, as there are libraries like TensorFlow that basically provides us this functioning. And then the top layer, I wanted to talk about the top layer. We basically use a sigmoid function. So I don't know whether you know or not the sigmoid function. I should carry a, okay, so I don't have that. So basically it uses a sigmoid function. I will add it in the slides after that. So after using all the neural collaborative filtering layers, we used a sigmoid function to create a score function. A score function can be seen as the indicator whether the user likes our item or not. So basically in the training step, we have the targeted value of the, suppose there is a user who has given 5 stars for our particular content that we have recommended. Oh, okay. So, so, right. Okay. So suppose a user gave a 5 star to our recommendation in the past, and then we are trying to find out whether another person will like it or not. So for that, we should think as if we have given the previous user the same recommendation, then whether he is going to like it or not. So in the training, we actually minimize the difference between the target and the score that we calculate. And then after training the model, we will calculate the scores for each of the items for each of the user. And then based on these scores, we make ranking for the user and then recommend the item for the uh, for that particular use. I guess it is going to be pretty much messy now. So is there any doubt in this? I personally feel that there is not much content here. Is there any doubt? Okay, so that's all for this slide. Yeah. So I have already linked these slides. You can check it. Okay, so is there any doubt in the slide? Okay, so I think there is no doubt. So we have 7 minutes remaining. In the meantime, I want to discuss the further logistics. So as you have read this documentation, previously we have said that the finally you are going to build your own recommendation system based on the different data sets. But now we are thinking to modify this evaluation process and this workflow of the project because there are many mentees and the data sets are not available that readily for the content based filtering. Basically, we are going to only focus on the content based filtering as as a thought previously. But now we are going to include the collaborative filtering also. So there are a few changes in the logistics that I will update soon. And one more thing, so the next time when we meet, we are going to work on the pre-processing of data. So I just wanted to know how many of you don't have a basic exposure to it. Like just give me a hand. Okay, wonderful. So everyone has a basic exposure to it. Basic exposure to Python.
Could you please repeat the question?
So does everyone have the basic exposure to Python previously? Okay, I will share a poll. I don't know how to see. Okay. So I will be sharing some of the resources for now for the Python stuff, and then we will be working on the data itself. So I guess everyone has seen the data previously. So the content-based filtering method is based on this data. That is the TMDB 5000 movie dataset. TMDB is basically a website same as of IMDb. So I think we can have a basic look at the data itself.
Where can we get the slides?
I have uploaded in the doc. If you have access to the doc, you can get the slides, or I will also give them after this.
Guys, the document which is uploaded, which is messaged in the group, has all the resources. So we will be using this document to compile all the resources further in the project. So everything will be accessed through that itself.
Okay.
And also to add on, today's session was just an introduction to what actually recommendation systems are. We would encourage you all to go through the slide once and try to read on yourselves the theoretical part of it. The actual implementation part will be commenced from the next classes. So if you get a brief understanding of what actual recommendation systems are, how do they work, it would be beneficial for you and everybody to understand whatever is coming up. So we would recommend you to go through some of the articles, resources, or any other relevant literature on recommendation systems, some of which we will try to share to you. Till we start with the actual hands-on work, it is recommended that you have a brief understanding of what the actual systems are, what type of methodologies do we use, and how do they actually work.
Because I just wanted to discuss this file, but I
Yeah,
don't
Dhruv, you may
think we
continue.
have time. Like we only have 3 minutes, so basically we are open for
Okay.
doubts for now. And
Guys, we have the last 3 minutes remaining. So anything that you want to ask related to the project or the logistics or the things that happened in today's class, you are free to shoot out your questions. We have about 2 to 3 minutes of time. Guys, you may unmute and start speaking.
you can also write it in the chat.
Hello, am I audible?
Yes.
Yeah, you are audible.
Dhruv, my question is that do we need any prerequisites other than basics of Python? Like, do we have to get any experience on hands-on experience on other libraries?
So I'm going to roll down 2 resources for NumPy and Pandas. These are basically within 30 minutes of resources. So you can watch out them. And after that, what will be used in the project, I will explicitly give it to all of you. And if there is another resource that I might think will be beneficial for you, you will get them out.